Okay, here's a wild thought for you. What if time itself doesn't move at the same speed for everyone? It sounds like something straight out of science fiction, right? But it is a fact. Time literally moves faster at the top of a skyscraper than it does at the bottom. And no, that is not a metaphor. It's one of the deepest, weirdest truths about our universe. And today we're going to find out why. No, really, this is a scientific fact. If you were to live your entire life on, say, the 100th floor, you would age just a tiny fraction of a second faster than someone living on the ground floor. Now, the difference is so small you would never ever feel it, but it's real, it's measurable, and it pulls back the curtain on just how strange the nature of time really is. Exactly, that's the question, right? How can time, which feels so constant, so universal, like a drumbeat for the whole cosmos, flow at different rates in different places? How can my now be just a little bit different from your now just because I'm a few hundred feet higher up? It's a puzzle that completely turned our understanding of reality on its head.
And to prove this isn't just some weird thought experiment, scientists have actually used atomic clocks. I mean, these are the most precise timekeeping devices humans have ever built. And when they put one on the ground and another at a higher altitude, the clock on top consistently, predictably, ticks just a few trillionths of a second faster. It's a tiny gap, for sure, but it is absolutely undeniable.
So where does the answer to this mystery come from? Well, for that, we have to go back over a century, to a guy you may have heard of, Albert Einstein. His general theory of relativity wasn't just about gravity. It was a whole new rulebook for space, and most importantly, for time itself.
See, before Einstein, pretty much everyone, including Isaac Newton, thought of time as this great cosmic river, just flowing at the exact same speed for everyone, everywhere. It was absolute. But Einstein came along and showed us that time isn't a rigid river at all. It's more like a stretchy, elastic fabric that can be warped and squeezed by gravity. And this leads us to the core idea here: gravitational time dilation. The principle is actually pretty simple, but its implications are huge. The stronger the pull of gravity is, the more it slows down time. So when you're on the ground floor of a building, you're just a little bit closer to the Earth's massive center. Gravity is slightly stronger, and because of that, time itself ticks just a little bit slower for you. Wild. Okay, I know. That is a mind-bending theory. But a theory is just an idea until it's been tested, right? I mean, how could anyone possibly prove that time itself actually slows down when gravity gets stronger? Well, the proof came back in 1976 with this absolutely brilliant NASA experiment called Gravity Probe A. What they did was, they took two super accurate atomic clocks and synchronized them perfectly. They kept one on the ground, and then they launched the other one 10,000 kilometers up into space, where Earth's gravity is way weaker. Then, after its little trip, they brought it back down to compare.
And the result? It was stunning. The clock that went to space had actually gained time. It was now ahead of its twin on the ground by this exact amount, a tiny but hugely significant fraction of a second. It was precisely what Einstein's theory had predicted, down to the decimal. The proof was right there. It was undeniable. Okay, so the effect is real, we've proved it. But you might be thinking, a few billionths of a second, so what? Who cares? Does this have any real impact on our daily lives? And the answer is a huge, resounding yes. In fact, you probably use the proof of this every single day. Just think about the clocks on GPS satellites. They're in this weird cosmic tug-of-war because of Einstein. First, because they're in weaker gravity, general relativity says their clocks should run faster, by about 45 microseconds a day. But at the same time, they're moving incredibly fast, so special relativity says their clocks should actually slow down, by about 7 microseconds. You do the math, and the net result is that every single GPS clock gets ahead by 38 microseconds every single day. Now get this, if the engineers who run the GPS system didn't constantly correct for that 38 microsecond drift, the whole network would basically become useless. The location on your phone's map would be off by several kilometers within just 24 hours. The fact that your navigation works at all is daily, tangible proof that time runs differently in space than it does down here on Earth. So we know that going up a few hundred feet has a tiny effect, and orbiting the Earth has a noticeable one. So the natural question is, what happens if we push this to the absolute limit? What happens to time when gravity becomes unimaginably, overwhelmingly strong?
Well, welcome to the neighborhood of a black hole. This is where gravity is so intense that it warps space-time into a pretzel. If a spaceship could somehow hover near the edge, the event horizon, its crew might experience just a few minutes passing, while for the rest of us back in the universe, thousands of years would fly by. Time, for them, would almost grind to a complete halt.
And this is what is so incredible. The very same physical law, this gravitational time dilation that forces engineers to make tiny adjustments to your GPS, is the exact same law that governs the most bizarre, extreme objects in the entire cosmos. It's a truly universal principle, from the top of a building to the edge of a black hole.
So let's bring all this back down to Earth. Literally, back to you. Because this isn't just about abstract physics and clocks, it's about biology. It's personal. Your physical position in a gravitational field actually affects the rate of your own biological clock. Your heart beats at a slightly different rhythm, your neurons fire at a different pace. You are literally aging differently depending on your altitude.
All of this forces us to throw out that old idea of time as some single, shared river we're all floating down together. The reality is, time isn't a universal current. It's a local phenomenon. It's something that is molded and shaped by the fabric of space-time right where you are. Every planet, every star, and yes, every single floor of a building has its own unique tempo.
So, the next time you ride an elevator, or even just climb a flight of stairs, remember this. You are literally traveling into the future, just a tiny, tiny bit faster than the world you left below. It really makes you think, doesn't it? Every move we make isn't just a journey through space, it's a journey through our own personal timeline. So, where are you headed?